Happy New Year, everyone. So today's topic is to do with SwiftUI OCR. So if your SwiftUI OCR app doesn't cache or hash images or persist scans, it's not a production ready app, it's more like a demo. Most tutorials work this way, as a demo, and then it breaks in a real app. Here's how I built a real OCR app in SwiftUI. As you can see, the user, they can select their image that they want to extract. And then the information, including the image, is stored in SwiftData. And it also shows the confidence on the detail screen. So this is the app feature that we'll be looking at today. View or file we'll be focusing on is the content view. As you can see, the content view, it uses dependencies and an OCR screen that also displays a child view that includes a list of scans and enables the user to navigate to the detailed view. But the main focus is the content view. So, what is the problem with this? On line 17, we inject dependencies at the root so the OCR screen stays testable. So that's not really a problem, but there's a better way of doing it. Now let's dive into the OCR screen. So on lines 33 to 36 or 37, so why this isn't production? There's no else branch, means unsupported formats will fail silently. So that's a big issue. And at the bottom of the view, between lines 55 and 57, why this isn't production, it's a big UI gap. We never present error message. In production, you add an alert binding so OCR failures don't silently disappear. So now we will fix the issue, and I will show you the production OCR screen. So here is the production OCR screen. On lines 35 to 40, we can convert to CGI image because Vision works best with that. And then also on line 63, this block here, overlay gives us a lightweight busy state. just show you the rest of the code. The next file we'll focus on is the app dependency file. Within the live function, it's a small dependency container that keeps things clean. Why this isn't production code, it typically includes a version OCR configuration, a signature so you can safely change recognition level, language, min, text, height, or at version without serving stale cache results. So this version contains the production ready code for app dependency. So within the live function, again, as you can see, the dependency container is now implemented correctly. So if you ever wanted to do unit tests, you can add a mock and swap in fake repositories plus fake OCR services, as seen here. The next file we'll focus on is the OCR processing signature. So within the struct default OCR signature provider, this is the key idea behind correct caching. And within this extension, we turn the signature into a stable string key for storage. The next file we need to create is our OCR result file, which is our SwiftData file. But at the moment, it's not production ready. As you can see, we store the image and the extracted text in SwiftData. So the reason why this isn't production ready, we only store the full image in a list. Decoding this repeatedly is slow. So now I'll show you the production version. Here is the production version. As you can see, we store thumbnails to keep scrolling fast. And that also helps for better performance within the app. Next week, we'll focus on more of the OCR services. If this topic is where you keep getting stuck in SwiftUI, that's exactly what I help people with in one-to-one mentoring. There's a free clarity call link in the description. Happy New Year, everyone. So today's topic is to do with SwiftUI OCR. So if your SwiftUI OCR app doesn't cache or hash images or persist scans, it's not a production ready app, it's more like a demo. Most tutorials work this way, as a demo, and then it breaks in a real app. Here's how I built a real OCR app in SwiftUI. As you can see, the user, they can select their image that they want to extract. And then the information, including the image, is stored in SwiftData. And it also shows the confidence on the detail screen. So this is the app feature that we'll be looking at today. The OCR service. So the purpose of the OCR service is to handle text recognition to enable the application to extract text using the device. So we need to create a protocol and also a struct. And then after that, we need to create another file that is called Vision OCR service. So the Vision OCR service contains a method called recognize text. Vision gives us OCR and we bridge it into async await. This wrapper is fine, but we're not treating it as OCR configuration as a first class signature, meaning caching can become very incorrect and error prone. But we can change this later within the production version of this class that we're implementing. And also after lines 47, we're using accurate recognition and language correction. Why this isn't production? Because these are hard coded, as you can see. If you change them later, your cache results might slightly become wrong for the new config. Production avoids this by providing a better storing mechanism. So this is the updated version of the production Vision OCR service class. As you can see, the updated part is the recognize text function. So what we're doing here, Vision is a callback base, so we bridge it using async and await. And this also gives us cancellation points and structured concurrency, which is much more cleaner than using traditional error handling. On lines 50, we configure Vision from the signature. And because the signature is stored, the cache validity stays correct even when we change these later. For image hashing class, we need to import CryptoKit. The image hashing class has a single function called hash. We hash the image so we can do cache lookups. And the reason why this isn't production ready, this hashes the raw CG image bytes. This can be unstable across different encoders, formats, metadata, and also color spaces. And there's a variation in pixel formats. So the result of the actual photo or image can be random because the hash may not be the same. So the production fix is by hashing a normalized representation like a JPEG or a PNG file. The next file is the OCR repository. The fetch result method hides SwiftData's details from the view model. And the reason why this isn't production as yet is because we're performing cache lookup, which is only by hash. In production, you also filter by processing signature key to guarantee the correct cache. And here is the updated OCR repository file. As you can see, most of the update has happened in the fetch result function. Cache hitch requires both hash and processing signature. That's what makes the cache correct. And also within the save method, repository owns persistence. In the next tutorial, we will focus on the OCR screen and the OCR details view. If this topic is where you keep getting stuck in SwiftUI, that's exactly what I help people with in one-to-one mentoring. There's a free clarity call link in the description. Happy New Year, everyone. So today's topic is to do with SwiftUI OCR. So if your SwiftUI OCR app doesn't cache or hash images or persist scans, it's not a production ready app, it's more like a demo. Most tutorials work this way, as a demo, and then it breaks in a real app. Here's how I built a real OCR app in SwiftUI. As you can see, the user, they can select their image that they want to extract. And then the information, including the image, is stored in SwiftData. And it also shows the confidence on the detail screen. So this is the app feature that we'll be looking at today. We will now implement one of our first screens. This is the OCR screen. As you can see, it contains a list, and within the list contains each of the scanned images. And if the user clicks on the disclosure, then it navigates to the details view. At the moment, this design is not production ready in any way. For example, on lines 38, there's no else branch. That means unsupported formats could fall silently. In production model, we would show a user interface that shows the actual errors. And then also, after line 55, we never present any error messages. In production, you add an alert binding so the OCR failures do not silently disappear. So now I'll show you the production example that includes most of the fixes. So here is the production version. The next view we would create is the OCR row view that displays the actual rows and the image with the description of each of the images that we're extracting. So on lines 20, we show the scanned image next to the extracted text that I mentioned earlier. This decodes the full image data for every row with a lot of scans. List scrolling can stutter. So obviously this is not production ready. So I will next show you the one that's production ready. So we're in the production version. As you can see, now we're rendering the thumbnail and not the actual image, and that will speed up the performance within the application. So the next view we need to implement is the OCR details view, and the details view shows the actual information that was fully extracted and retrieved from SwiftData as well. As you can see, the details screen is simple. It just includes image, text, and confidence. As you can see here, within the preview. In production, you might also show language detection that will include allowing reprocessing, copy, share actions, or a rerun of OCR. The next file we need to create is our image picker button that will enable the user to click on the button and select the image from the phone's camera. On lines 23, we're using the photo library's picker for simplicity, but there's a better way of doing this. This is not production ready at the moment. For an OCR scanner app, you usually use VisionKit document camera for better props, perspective corrections, and multi-page scanning, and we will implement that in the production version. So here's the production version of the image picker button. This view is intentionally small and reusable, so it makes it easier to test. It doesn't know anything about OCR. It just picks an image. Instead of owning logic, this view communicates via closures, as you can see on lines 21, 22. That keeps it reusable and testable. On lines 28, we explicitly guard against disable state, so the user can't spam the button while the OCR is running. Because sometimes if you don't do this, the user can keep on clicking the button repeatedly. On lines 33, disabling the button is a UX signal as well as a safety net. Lines 35 to 36. This uses the UI image picker controller for simplicity. In a real scanner app, you'll likely swap this for VisionKit's document camera, but the rest of the pipeline wouldn't need to change. On line 42, we always dismiss the sheet before passing data back. That avoids UI race conditions and stop presentations. And for the cancel section, it's treated as a first-class path, not something we silently ignore. So the next file that is needed is our image picker, the UI view controller, representable. It looks okay, as you can see, but really it's not. It's not production ready. There's no cancel callback, no source type set, and no permissions messaging. Production handles cancellation and UX edges explicitly, but it doesn't happen here though. So let's see if we can solve that right now. Here's the production ready image picker. As you can see on lines 12 to, lines 13 to 14, this wrapper bridges UIKit into SwiftUI. SwiftUI doesn't have a native photo picker with full control yet. So we adapt the UI image picker controller. And also with the make UI view controller, that is called once when the sheet appears. And the sheet would be your photo view to select the picker, to select your image, And also for the source type, that is assigned to photo library. But in production, you might change it to camera. All you have to do is just type in .camera instead of photo library, or make it configurable another way. Oh. Yeah, it did only for a little bit. I'm still doing it that way anyway. Yeah, I'll be finished in like 3 minutes anyway. Just have to pause it each time. Yeah, you can just leave it in there if you want. I'm just gonna continue now anyway. Yeah, okay. Is that one done? Yeah, I think that one's done. Because I don't think. Yeah, okay. Yeah. You want to eat around the table, don't you? Yeah. Yeah, I'm gonna just gonna save it. I'm gonna say one more thing. Yeah, that's that. Yeah. I don't know what he's saying. I know, it's just that I'm tired. No, I don't know what he's saying, Probably said it maybe about 5 times all of my videos. Because I'm tired. If this topic is where you keep getting stuck in SwiftUI, that's exactly what I help people with in one-to-one mentoring. There's a free clarity call link in the description